Why think anymore? What is the purpose, when there are so many out there that are offering to think for you, or telling you the answers to your problems? Thinking is actually hard work. This slide, from a Google search, provides a definition of thinking. There are several key phrases in this definition: consider or reason, rational judgment, and the word intelligent. Maybe artificial intelligence can help. Again, from a Google search on the phrase artificial intelligence, we find this definition. Perhaps we can make the link through the term intelligence, and suggest that one might expect an artificial intelligence to be capable of thinking. We might expect an artificial intelligence to be able to consider or reason about information, and be able to apply rational judgment to make decisions. We might expect an artificial intelligence to be able to apply rational judgment in order to allocate resources, while exerting control in pursuit of its goals. Now to consider the process of thinking to solve problems. If you have very simple problems, you can be given a script or detailed procedure to follow. For example, if you are asked to add 1 plus 1, you get 2. It's a rule. If you are told to put the square peg in the square hole, it's not that hard. You just put the square peg in the square hole. It's a rule. If the concept of rules sounds familiar, computers have been processing if-then-else rules since the conditional branch was invented. That was a long time ago. A very long time ago. So you added 1 plus 1 and got 2. Is 2 enough? You are driving your car and put 1 pound of pressure on the accelerator. Is that enough? Is it too much? When should you press harder? When should you decrease pressure? When should you apply the brakes? How much? You have to adjust your MRI machine. How much should you adjust the scanner settings to produce the desired contrast between different body tissues? There are a group of unknown individuals coming toward you. It is dark. What should you do? Hide, run away, draw your weapon, or hope there is nothing to be concerned with? You consider your situation, and use judgment and reasoning to decide what to do, including how to respond, and potentially where and how much to respond. For humans, it is safe to suggest that judgment requires thinking. It requires the human to consider the situation, and the information available, to make decisions and to control actions. Regarding humans, have you ever thought about asking a human, "What were you thinking?" The other driver, when he ran the red light and ran over the pedestrian. The waiter that spilled the tray of food in your lap. The politician, when he voted in favor of allowing unlimited donations to his political campaign. The man with the gun, that shot at the driver of another car and hit the child playing in her living room. The repair person, that cut your gas line that caused your home to explode. Your employee, that was using the company plane for personal vacations. Your boss, that embezzled $50 million from the employee retirement fund. Your doctor that was prescribing opioids at 100 times the normal dose. If you got a response, was it something like, "It seemed like the right thing to do at the time"? Or, "I don't know"? Switching gears, humans built machines to give them access to more power. They built machines to increase speed. And they built machines to increase the quality of the goods they were producing. And since it's all about the money, they were pursuing the goal of smaller, cheaper, and faster. With artificial intelligence, humans are attempting to create machines that retain their power, speed, and precision advantage over humans, and add to that the intelligence to solve more complex problems so the machines can pursue goals on their own. There are also cases where the business driver is to create intelligent machines that will keep humans out of harm's way. In other cases, there is a desire to create machines that can go where humans cannot go. At the same time, they want to avoid some of the behavioral problems that humans have demonstrated. It should not be too hard to understand that when machines are mass-produced with artificial intelligence, that their behavior must be explainable and auditable, and fixable if necessary. Consider an autonomous flying machine with a gun, sometimes referred to as an unmanned combat aerial vehicle. If that machine decides on its own to engage a target, and there are civilian casualties, then someone is going to demand to know why. And since the behavior may be mass-produced, there would be the potential for repeated catastrophic events resulting in mass casualties. The potential for mass-produced friendly fire incidents is easy to comprehend. Not all failures of artificial intelligence will result in physical harm, but when the intent is to provide solutions that are better than those provided by humans, there must be a way to ensure that the results are the best possible. Similarly, these artificial intelligence-based machines will be continually enhanced with access to better information sources, advanced sensors, and access to better data. This means that it must be cost-effective to extend their cognitive behavioral models. If it is impossible for the artificial intelligence to explain how it thinks, then it will be impossible to extend the models and have confidence in the new and modified behaviors. So, how can one develop these artificial intelligence solutions that are easy to create, easy to audit and explain, and easy to fix and extend? One approach that is available today is CumpSim's Knowledge Enhanced Electronic Logic, or KEEL technology. First, KEEL provides a new way to process information. KEEL cognitive engines process information collectively, during a cognitive cycle. This means information is effectively processed together, not sequentially, and not in parallel. This allows the system to think, in a similar analog fashion to how a human applies judgment and reasoning to address multiple objectives simultaneously, and balance interrelated options to make the best decisions. Second, KEEL technology provides a new way to tell the system how to think. The KEEL dynamic graphical language makes it easy to give the machine a visual value system. A value system is necessary to give the machine a way to interpret valued influencing factors. The KEEL dynamic graphical language also makes it easy to define functional relationships between influencing factors and integrate those factors to drive decisions and actions. No higher-level mathematics skills, and no programming experience are required to create the behavioral models. The KEEL dynamic graphical language also provides the mechanism for auditing the behavior of the artificial intelligence machine. Using a technique called language animation, you can watch the system think. It takes only a few days to learn how to create the cognitive models, and only a few minutes to gain the skills necessary to audit the behavior of an autonomous system. KEEL technology is available today. This makes it easy for you to tell your systems how to think, and how to adapt in today's complex dynamic environments. KEEL-based artificial intelligence can be applied to any market that would benefit from expert decisions and expert adaptive operational control. It has the added benefit of providing 100% explainable and auditable behavior, that is necessary for many safety-critical applications.